Hello everyone, good evening to each and everyone. I all of you welcome on Gate Wallah English channel. We are studying signals and system in very much comprehensive manner, and we just started chapter number 1, introduction to the signals and system. Already we completed total 6 lectures and this is lecture number 7. We are studying first chapter, introduction to the signals and system, in which we are studying some standard signals. I completed some standard signals, all the standard signals, basic understandings of standard signals in continuous time, and from today I am going to discuss discrete time signals. Okay, so first of all tell me, am I audible properly? Audio and video both are clear to you or not? Am I audible properly, guys? Audio and video both are clear or not? So this is lecture number 7. This is the lecture number 7, some standard signals, part 6, guys. And today's topic is some standard signals in some standard discrete time signals, guys. Okay. Okay, so let us start, guys. Let us start now. First of all, all clear? Okay, fine. So first, impulse, discrete time impulse function, or it is also known as Kronecker delta function. Discrete time impulse function, or it is also known as Kronecker delta function. Like continuous time impulse function, it is also known as direct delta function. So this is discrete impulse function, it is also known as Kronecker delta function, guys. Okay. So here, now this is the discrete time signal, so that's why square bracket, which is equal to del n, del t, instead of del t it's del n, okay, and here this del n is equal to now amplitude is 1 at n equal to 0, guys. Whenever n equal to 0, amplitude is 1 and it is 0 when n is not equal to 0, guys. Correct? So in continuous impulse function, amplitude is infinite as t tends to 0, guys. But here amplitude is 1. Amplitude is 1 at n equal to 0 and amplitude is 0 other than n equal to 0, guys. And here strictly n is only integer, values of n are valid here, guys. Okay. So graphically it looks like this. On x-axis n, only integer values of n, guys, only integer 1, 2, 3, minus 1, minus 2, minus 3 and so on, guys. Okay. Amplitude can be integer or it can be non-integer, guys. Discrete time, amplitude can be integer, can be non-integer. So here sample amplitude is 1 at n equal to 0. This is known as sample, guys. In discrete time, this is known as sample, guys. Your sample, this sample is located at n equal to 0. At n equal to 0, sample amplitude is 1. Here amplitude, guys, not area, not weight. Here sample amplitude is 1, guys, and other than 0, sample amplitude is 0, guys, like this, 0. Okay. So this is the discrete impulse function. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Discrete time signal is not defined for non-integer value of n, guys. Remember this thing, only integer values on x-axis are valid. Here signal is not defined for 1.5, like 2.6, 3.1757, correct? Only integer values of n is valid, guys, this is known as sample, and here sample amplitude is 1, guys. Okay, sample amplitude is 1. If I am talking about del t, guys, if I am talking about del t, continuous time impulse function, then amplitude is infinite as t tends to 0, ideally speaking, and amplitude is 0 at t is not equal to 0. Okay, so this is the difference between continuous impulse function and discrete impulse function, guys. Okay, suppose I am asking to draw x of n is equal 4 del n minus 2, guys. So tell me, what is the location of this sample, we can say, or impulse function, okay, where this impulse function is located, and what is the amplitude of the impulse function, guys? This is the discrete impulse function, Kronecker delta function. So as you can see here, n become, see, what is the standard method? Left hand side, n become n minus 2. So right hand side also everywhere, amplitude is 4. Right hand side also n become n minus 2, guys. Here you are replacing n with n minus 2. So right hand side also everywhere, n become n minus 2. Amplitude is 4. So this is 4 and it is located at n equal to 2. So at n equal to 2, sample amplitude is 0, and other than n equal to, sample amplitude is, so sample amplitude is 4 at n equal to 2, and sample amplitude is 0 at n is not equal to 0. So this is located at n equal to 2, guys. This is located at n is equal to 2. Okay, having amplitude 4, guys, and other than n equal to 2, amplitude is 0. So this is 0, 1, 2, 3, 4. N is not equal to here. N is not equal to 2. Okay. This is minus 1. This is minus 2. This is minus 3. Here sample amplitude is 4, guys. Sample amplitude is 4. Now suppose I am asking to draw x of n equal to minus 3 del n plus 4. What is the location of this sample? What is the amplitude, guys? What is the amplitude? You can see here, this sample is present at n equal to minus 4, having amplitude minus 3, guys. This is present at n equal to minus 4, minus 1, minus 2, minus 3, this is minus 4, minus 5, 0, 1, guys, and amplitude is here 4, 0, 1, minus 1, minus 3, minus 4, minus 5, amplitude is minus 3, guys, correct? Okay. Now suppose I am asking to draw x of n, time scaling 2 times del 3 into n, guys, 3n. Then what is the location of this impulse, and what is the amplitude, guys? What is the amplitude? Anyone in the comment box? Anyone, guys? Tell me. What is the amplitude? What is the amplitude of this impulse function? So as this is the discrete time, signal, guys, so directly you can do it, guys. Left hand side n become 3n, guys. Here n only integer value, like 1, 2, 3, 4, 5. So multiplication also integer value. So it is 2, guys. N become 3n is equal to 0, guys. Are you getting, guys? Left hand side n become 3n. So right hand side also everywhere n become 3n. So here this is 2 and n is equal to 0. So here it is 0 at n is not equal to 0, and this is nothing but del n. Can we say like this? Nothing but 2 times del n, guys. Yes or no? Okay. So here this impulse is located at origin. This impulse is located at n equal to 0, guys. At n equal to 0, origin only, guys. Origin only, correct? Having amplitude is 2, guys. Amplitude is 2. This is 0, 1, 2, 3, 4, -1, -2, -3, -4, guys. So del 3n equal to what, guys? Del n. What you can say? Del 3n is equal to del n, guys. Okay, so there is no impact of time scaling on impulse function, guys. We can see here del 3n is equal to del n, guys. Yes or no? So now what is the conclusion? In continuous time, guys, continuous time, we know that del alpha t, time scaling property, nothing but 1 upon mod alpha into del t, guys. But in discrete time, it is del k into n, guys. K into n, del kn, which is equal to del n only, guys. Correct? So this thing you have to write in the short notes, guys. The difference. Okay, this is the difference. Is this clear? Is this clear to each and everyone? Fine. Okay, so this is what, guys? This is the discrete impulse function. This is all about discrete impulse function. Now we have seen that different properties of continuous impulse function. In similar manner, we will see the properties of discrete impulse function also, guys. Discrete impulse function also. So next is properties of discrete delta function or discrete impulse function, guys. Okay, discrete means discrete time impulse function or Kronecker function or discrete delta function. So we will compare. First of all, we will write the property for the continuous impulse function, and from that only we will write the property of discrete impulse function. Okay. So here what you have to remember, just remember this thing. Here I am writing for the continuous time signal, guys. I am writing for the continuous time signal, and here notation for the discrete time signal. Notation for the continuous time signal and for the discrete time signal. Okay. So here x of t, guys. Notation for the continuous time signal x of t. Then here it is what? X of n. Here round bracket, here square bracket, here t, which is integer non integer both valid, here n, only integer value of n, guys. Okay. Here on x axis time t, then here on x axis time n, guys. Again here integer non integer both valid, here only integer value of n. Now here suppose shifting, so t naught, suppose shifting t naught, t minus t naught, like, then here it is n naught, guys, n naught. Then here we are using one variable tau, so here we will use k, guys. Here we will use k, guys. Suppose here fundamental time period capital T, then here the fundamental time period is capital N. Again here integer non integer both possible, but here only integer value of n, guys. Here this capital N indicates number of samples, like here n also, number of samples, guys. Okay, so only integer values are valid. In continuous time we are doing integration, guys, integration of x of t, whereas in discrete time it should be what? Tell me, guys. Here integration. In continuous time, if it is integration, then discrete time, tell me. In discrete time it is, in continuous time, if this is integration, and discrete time, then what you have to do, guys? Continuous time we are doing integration of x of t, then here discrete time, only discrete samples. Yes, very good, guys. Very good. Summation. Summation, guys. Summation. Okay. Here in continuous time, we are doing differentiation of x of t. Differentiation of x of t, guys. Differentiation of x of t. Then here, in discrete time, we have to take the difference, guys. Difference. This is the first order differentiation of x of t. Then here, first order difference, guys. This is what? First difference. First difference, guys. With example also, I will tell you guys. First difference. See, first difference means what? Suppose x of n is there. X of n. Then its a first difference is given by. First difference. First difference of x of n is equal to x of n minus x of n minus 1. This way we are defining the first difference of x of n, guys. With example also I will tell you, don't worry. With example also, guys. So if suppose someone is asking first difference of x of n signal, then it is nothing but x of n minus x of n minus 1. So this is the first difference of x of n, guys. Clear? Okay. Okay, guys. So now let us continue here. Continue. Property. So in continuous time, guys, if I am talking about the continuous time, so first property is what? Area property. Area under continuous impulse function. Area under del t. What is the answer? Tell me. What is the area of del t, guys? Total area of del t? Nothing but 1, guys. Correct? Area under impulse is always 1. So in similar way, guys, similar way, what is the area? Area of discrete. What area means? Summation. If you do the summation of all the samples from n equal to minus infinite plus infinite, meaning of this is nothing but what? Summation. Summation of all the samples amplitude, guys, or we can say summation of amplitude of all the samples from n equal to minus infinite to plus infinite. Okay. So if you do the summation of all the samples amplitude, then it will be, tell me, guys. If you do the summation of all the samples, summation of all the samples. So here amplitude 0, amplitude 0, amplitude 0, amplitude 0, here 1, 0, 0, 0, 0. So if you do the summation of all the amplitudes of the samples, then tell me what will be the summation? What will be the summation of amplitude of the samples? Yes, very good, guys. 1. Very good. So 1 will come into picture, guys, here. So summation. Now see integration, then summation here. Here integration t equal to minus infinite to plus infinite. Here summation n equal to minus infinite to plus infinite. Here del t, here del n. Okay. And the summation is 1, guys. So this is what first area property we can say. Now second, scaling property in the continuous, scaling property for the continuous impulse function. So here it is del alpha t, which is equal to 1 upon mod alpha del t, guys. Correct? 1 upon mod alpha del t. So in similar way, just we have seen that del m into n, guys, where m is a scaling factor. Here alpha is a scaling factor. In similar way, here m is a scaling factor, guys. M is a scaling factor. So what will be the answer, guys? So here del n only, guys. Del n only, guys. Correct? So this is what second property, that is scaling property. Third property is product property. If any general signal x of t is multiplied with impulse located at t naught, then the answer will be x of t naught into del t minus t naught, guys. Del t minus t naught. Correct? This is the product property. In the similar way, we can write the product property for the discrete impulse function also, guys. Discrete impulse function also. So here it is x of, instead of x of t, it is x of n, guys. Here del t minus t naught. So here I am writing del n minus n naught. Correct? Del n minus n naught. So what will be the answer, guys? Correct? X of t, x of n. Del t minus t naught, del n minus n naught. This impulse is located at t naught. This impulse is located at n naught. So again, answer is same, x of n naught. Buy one get one free, guys. Buy one get one free. Correct? Buy one get one free offer. Fine. Clear to each and everyone? Tell me, any doubt in this? This is very much easy to understand from the by comparing with continuous time, comparing this discrete time property with continuous time property. Okay. So this is the product property. Again, you can put the value of t naught equal to 0, then it will be x of 0 del t, and here n naught equal to 0, then it will be x of 0 into del n, guys. Fine. So this is the product property. The similar way, fourth property is sampling property. So here, if you do the integration from minus infinite plus infinite x of t into del t minus t naught into del t, then it is nothing but what? It is nothing but x of t naught, guys. X of t naught, correct? X of t naught. And in the similar manner, here also we can write, instead of integration, here summation. Here integration n equal to minus here integration t equal to minus infinite to plus infinite. So here summation n is from minus infinite plus infinite x of n into del n minus n naught, correct? Summation n is from minus infinite to plus infinite x of t, x of n, del t minus t naught, del n minus n naught, and the answer is x of n naught, guys, correct? X of n naught. No, FFT is not there in your syllabus. No FFT and digital filters, guys, up to only DFT. Okay. Now fifth property, guys. Do you remember fifth property? The property is what? So here, any general signal x of t, guys, any general signal x of t can be represented in weighted and shifted impulses x of tau into del t minus tau d tau. Do you remember? Any general signal is represented in weighted and shifted impulses, and here tau is from minus infinite to plus infinite, guys, correct? The similar way here also same thing, guys. Any general signal x of n, any general signal x of n, instead of integration, here summation, guys, x of tau. So instead of tau we can write x of k, guys. See here, just wait for a minute. So here you can see, guys, here notation is tau. So instead of tau in discrete time you can take k, guys, k. So x of tau, x of k, okay, and here del t minus tau. So tell me here it is what? Tell me in comment box. Instead of del t minus tau, so what I have to write here in the bracket? What I have to write, guys? Tell me in the comment box, each and everyone. I am expecting answer from each and everyone. I am expecting answer from each and every student. Tell me in comment box, guys. Yes, very good. You got the point, guys. Of t here n, here k, and here tau is from minus infinite to plus infinite. So here variable is k, guys. K is from minus infinite to plus infinite, guys. Got it? So these are the different properties of continuous impulse function and discrete impulse function, guys. Okay, got it now? Any doubt? Tell me. Okay, now last property is very much important. We have derived some important result from the last property, this shifting property. Do you remember? Like impulse function, sorry, step function can be represented in the impulse function. Okay, so what I am saying, guys, what I am saying, from the last property, if you put x of t equal to u of t, if you put x of t equal to u of t, then it will be what? You remember, u of t integration tau is from 0 to finite del t minus tau d tau guys, and t minus tau equal to lambda, then one more format you will get q of t is equal to here del tau d tau. This case tau is from minus infinite t guys, correct, minus infinite to t, and differentiation of this one del t is nothing but first order differentiation of step function. Now first I will tell you same thing for the discrete time by comparing with continuous time guys, and later we will see with example also guys. Okay, so tell me here for the discrete time, instead of u of t it is q of n guys. By comparing u of n, summation, here summation guys, del here n minus k, tau 0 to infinite, here k is from 0 to infinite guys. Okay, so I told you by comparing guys, I said by comparing with continuous time, later we will see with example also guys, with example. Okay, and here same thing guys, if you replace n minus k with delta, then it will be q of n by comparing with this summation, here del tau, here it is del k, where k is from minus infinite to n guys, minus infinite to t, here minus infinite to n guys, del tau del k, and this is guys del n, here differentiation guys, here differentiation of u of t. So here first difference of u of n guys. Okay, see here the first order differentiation of u of t, then here it will be first difference of u of n. So tell me what is the first difference of u of n? I already told you guys. What is the first difference of u of? What is the first difference of u of n guys? Tell me what is the first difference of u of n? Tell me the first difference guys. What is the first difference guys? Can you tell me the first difference? U of n minus u of n minus 1. Very good guys, very good. U of n minus u of n minus. So just we wrote by comparing with continuous time. Okay, now I will prove this also guys by graphical method also. Okay, so this is all about what guys? These are the different properties of discrete delta function or discrete impulse function. Now next function is in discrete time signal, next function is unit step sequence guys, like unit step function in continuous time, in the same way unit step function for the discrete time guys. Okay, so here x of n is equal to q of n guys, correct, instead of u of t now u of n. So here this q of n is equal to 1 for n greater than or equal to 0. Now in continuous time there is a discontinuity in amplitude at t equal to 0, sudden change in amplitude at t equal to 0, but here as this is the discrete time, there is no discontinuity in the amplitude, there will be no sudden change in the amplitude for the discrete time signal, and in discrete time signal there will be no sudden change in amplitude. Okay, because this is the discrete time, not continuous time, that's why. So that's why here I am writing greater than or equal to 0, okay, and less than 0. See, there is no sudden change in amplitude at n equal to 0. Okay, there is no sudden change in amplitude at n equal to 0, as this is the discrete time. So that's why here I am writing n greater than or equal to 0. But in continuous time there is a discontinuity, or there is a sudden change in amplitude at t equal to 0 from 0 to 1. That's why amplitude is not defined at t equal to 0 for the continuous time unit step function. Okay, so here it is how to represent this graphically guys. So here for less than 0, for less than 0 means starting from n equal to 1, n equal to minus 1 guys. Remember this thing, n less than 0. What is the meaning of n less than 0? So that means it starts from the n equal to minus 1 because only integer values. So less than 0 means starting from n equal to minus 1. So n equal to minus 1 0, n equal to minus 2 0, yes or no? Are you getting? Now n greater than or equal to 0. So at n equal to 0 amplitude is 1. At n equal to 1 amplitude is also 1 guys. N equal to 2 amplitude 1 guys. At n equal to amplitude 1. At n equal to 3 amplitude is 1. At n equal to 4, n equal to 4 amplitude is 1 guys. Correct? So here amplitude is sample amplitude is 1 guys, and so on up to infinity guys. So n equal to 0, 1, 3, only integer values 4, minus 1, minus 2, and amplitude is 1 guys. Okay. So these are the different samples guys. This sample is at n equal to 0. This sample is at n equal to 1. This sample is at n equal to 2. This sample is at n equal to 3. This is at 4. Now, can we represent these all the samples in the form of del n? Can we represent this sample in the form of del n? Tell me, yes or no? So if you want to represent this sample in del n, then what should be the answer guys? What should be the answer? This sample only this sample in the form of del n, guys. What is the answer? So it is nothing but impulse at, this is what, sample at origin having amplitude 1, so it is nothing but del n, correct? Similarly, this sample guys, so this is at n equal to 1, this is at n equal to 1, this is at n equal to 1 having amplitude 1, so this is nothing but what, del n minus 1, this is at n equal to 2, this is at n equal to 2 guys, this is at n equal to 2, so can we write like this, del n minus 2 and so on guys, correct? Okay, very good guys, fine. So can we write like this, Q of n is sum of different impulses like del n plus del n minus 1 plus del n minus 2 and so on. Can we write like this, del n plus del n minus 1 plus del n minus 2 plus del n minus 3 and so on, yes or no? Okay, very good. Then here it will be Q of n equal to, now summation guys, summation here del n minus 1, so let me write like this, del n minus k, then what will be the limit, k starting from, tell me the limit, lower limit and upper limit, can tell me in the comment box, tell me what will be the lower limit and what will be the upper limit, k starting from, k starting from 0 to infinite, very good, k starting from 0 to infinite, starting from n equal to 0, starting from k equal to 0, and this is going up to infinity, so that's why 0 to infinite. So we got the same answer, you can see here, we got the same answer. Here we wrote, correct, we wrote using by comparing with this one guys, I wrote by comparing with this one, okay, by comparing with continuous time, buy one get one free offer, buy one get one offer here guys, but here conceptual, conceptual guys. First I define unit step sequence, and from this I wrote this and derived this one. Got it? So this is the first format. Okay. Now here let us consider lambda is equal to n minus k guys. Lambda is equal to n minus k, correct? So here what we can write here in this case, if k equal to 0 guys, if k equal to 0, then what is the value of lambda? If k equal to 0, lambda n guys. K is equal to infinite. What is the value of lambda? If k equal to infinite guys, if k equal to infinite, lambda is minus infinite guys. Okay, then here your u of n is nothing but summation. Now lambda is from n minus infinite till lambda. Here, okay. Now here if you interchange the limit of summation, then is there any change in answer guys? In discrete time, in the summation, if you interchange the limits of summation, then is there any change in answer? No guys, there is no change in answer. Suppose if you are doing integration summation from 1 to 4, or you are doing summation from 4 to 1, you will get the same answer. See, if you are doing summation of all the samples from 1 to 4, 1 plus 1 plus 1 plus 1, that is answer is 4 guys. If you do the summation from 1 to 4, and in similar way, suppose if you do the summation from 4 to 1, 1 plus 1 plus 1 plus 1, then also 4 answer guys. So in discrete time, in summation, if you interchange this lower limit, upper limit, then there is no change in answer guys. There is no change in the answer, correct? Okay. So here we will get the same answer to interchange this limit minus infinite and this till lambda, and let us take lambda equal to k now guys. Let us replace lambda with k. So if lambda equal to k, now lambda equal to minus infinite, k equal to minus infinite, lambda equal to n, k equal to minus n. So here we will get now q of n, which is equal to summation say k from k is equal to minus infinite to plus infinite. Clear? Fine. So this is the second format we derived. Means unit step sequence you can represent in the impulse train guys, or impulses. So see here we got the same answer. Here we got by comparing with this one guys, buy one get one free offer. Okay, comparing with continuous time, and here we derived. Got it? Clear to each and everyone? Any doubt in this? This is very much important. Now see, this is u of n starting from n equal to 0. Okay, starting from n equal to 0 and going right hand side guys, because n positive, that means right sided signal. Same as continuous time. In continuous time also I told you, if t is positive, then from starting it goes towards the right side. In the similar way here also same thing guys. Here plus n starting plus n, that means right sided signal, and starting from is n equal to 0. Starting point is n equal to 0 guys, correct? Now suppose I am asking to draw x of n is equal to q of n minus q of n minus 1. So this is also right sided signal, this is also right sided signal. This will start from n equal to 0 going towards right side. This will start from n equal to 1 and going towards right side. Yes or no? Correct? Okay, right side opposite sign. So first I am drawing u of n. I am here drawing u of n. This is u of n, and here this is u of n minus 1, and this is the resultant signal u of n minus u of n minus 1, that is x of n. On x axis only integer values of n are valid guys. Here I am writing q of n. Here I am writing q of n minus 1. This is the resultant signal x of. Okay. So here this is u of n starting from n equal to 0. Right side signal 1, 1, and so on. Yes or no? Minus 1, minus 2, minus 3. Amplitude is 1, guys, correct? This is u of n. Now this is u of n minus 1. Starting from n equal to 1, n equal to 1, guys. Amplitude again 1, equal to 2, equal to 3. Okay. So starting from n equal to 1 and going towards right sided, because right sided signal is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. And here amplitude is 1, guys. 1, correct? Now see, if you do the subtraction, guys, sample by sample, time by time, subtraction of all the samples. So here what will be the resultant signal, guys? Here see, this 0 minus 0, guys. 0 minus 0, so the answer is what? 0, guys, correct? 0, sample amplitude is 0 for minus 1, minus 2, minus 3. Here also sample amplitude is 0 for minus 1, minus 2, minus 3. 0 minus 0, answer is 0, guys. Now at n equal to 0, and n equal to 0, this is 1, and here this is 0, guys. So 1 minus 0, it is 1, guys, correct? 1 minus 0, it is 1. And for n greater than or equal to 1, guys, here see, here you can see, guys, here you can see, for this 1, 1, 1, 1, and here also, guys, same thing, 1, 1, 1, 1. So 1 minus 1, 0, 1 minus 1, 0. At n equal to 1, you can see n equal to 1, 1 minus 1, 0. N equal to 1 minus 1, 0. At n equal to 3, 1 minus 1, 0, guys. Also 1 minus 1, 0. Yes or no? Correct? So here, what will be the resultant signal after subtraction? So after subtraction, you will get samples only at origin, guys. Only at origin having amplitude 1, and other than 1, you will get the 0, guys. Here also, correct? 1, 2, 4, 5, minus 1, minus 2, minus 3, amplitude is 1. So this is nothing but what, guys? This is nothing but del n, the resultant signal, u of n minus u of n minus 1, which is equal to del n. So finally what we got, guys? Got del n, nothing but first difference of unit step sequence, unit step function, guys. Yes or no? Correct? Okay. Clear to each and everyone? Any doubt in this? So we got the same answer. You can see here. We got the same answer. Correct? We got the same answer. U of n minus u of n minus 1, which is equal to del n. Here I wrote using by comparing with this one, guys. But u of n minus u of n minus equal to del n. So this is nothing but what? First difference of u of n. Any doubt? Any doubt, guys? Tell me, guys. All of you are enjoying this type of content? In comment box, tell me the feedback. Is this fine, each and everything, like teaching style and presentation? Is this visible properly? Handwriting, each and everything, presentation is fine. I want some feedback from you people. I want some feedback from you people, guys. Okay, okay. So let us continue further. Thank you so much for your feedback. I hope all of you are enjoying this type of content. And this is the premium content, guys. Premium content. Now, suppose I am asking to draw. Suppose I am asking x of n equal to amplitude is 3, q of n plus 2, guys. Tell me, this is right sided, left sided, and starting point. Right sided, it will go right side, left side, and what will be the starting point? What will be the starting point? Right side, left side, and what will be the starting point? Right side, left side, what will be the starting point? So how to decide whether this is right side or left side? Here plus sign, so right side. Right side means opposite side. It will start from n equal to -2 and goes towards right side, having amplitude 3, guys. Having amplitude. And I hope all of you are getting. And I hope all of you are getting class notes also, guys, from application. Are you downloading the class notes? Are you downloading the class notes, guys? From application, you can download daily class notes also, guys. Need not require to note down in live class. Need not require to note down all the things in live class. Simply, you can download it from the application. Every day we are uploading class notes. Okay, very good. So here it will start from n equal to -2 going right side, having amplitude 3. Right sided, starting from its -2 opposite sign. So less than -2 0, -4, -3, amplitude. Okay, amplitude is what? 3. Amplitude is 3. Now suppose I am asking to draw x of n is equal to amplitude is 2, q of -n plus 1. So tell me, right side, left side, and what will be the starting point? Right side, left side, and what will be the starting point? What will be the starting point? Gradually I will increase the duration of class also, guys. Gradually I will increase the duration of class. As of now I am taking class between 60 minutes, 60 to 75 minutes. Okay, and gradually I will increase this duration also. Okay, but I will complete all the topics in very much comprehensive manner, guys. Premium content you will get with sufficient number of questions. Okay, and I will try to finish this subject as soon as possible. As soon as possible. Okay, now see here -n, so that's why left side, that means starting point same sign. So left side and start from the n equal to 1. Okay, see, this is the left side starting from n equal to 1. You can follow the standard method also, guys. You can follow the standard method also. What is the standard method? 2 q of -n plus 1, guys. -n plus 1. So here it is equal to amplitude is 2, left hand side n become -n plus 1, right hand side also everywhere n become -n plus 1. Correct? Left hand side replacing n with -n plus 1, right hand side also everywhere -n plus 1. You can see here n less than or equal to 1 and it is 0 for n greater than 1. Standard method also you can follow, and shortcut also, guys. Shortcut is same as I already told you in the for the continuous time signal. So starting from n equal to 1 and going towards left side. Left sided signal. Okay. You can share this content with your college friends also, guys. Those who are preparing for GATE exams, GATE exam, okay, and other competitive exams also. This is 1, -1, -2, -3, 5. Amplitude. What is amplitude, guys? Amplitude is 2 x of, done. Okay. Any doubt? Any doubt? Now suppose I want to write this signal in the form of impulse train, guys. So impulse train. So how to write this signal in the form of impulse train? Observation. Suppose x of n in the form of impulse. So summation here I am writing del n minus k will come into picture, correct? N minus k. Now tell me, k starting from what? Lower limit, upper limit. K starting from, see here you can see, guys. Here you can see k starting from 0 to infinite. For this k starting from 0 to infinite, guys. 0 to infinite, correct? Starting from 0 to infinite. Then tell me for this. K is starting from what? Del n minus k is fixed. Del n minus k is fixed. Starting from, for this signal, I am talking about this signal. Starting from yes, it is starting from -2 to plus infinite, guys. -2 to plus infinite. Are you getting? Starting from -2 and going towards plus infinite. In the similar way, suppose observation x of n, I want to write this signal is the form of impulse. So summation, tell me, del, here also I think I can write same thing, n minus k. Here del n minus k is fixed. What is the limit? K is starting from, tell me. K starting from here. Tell me, guys. K starting from 1 to minus infinite, or you can write minus infinite to 1 also, guys. You can write minus infinite to minus infinite. Last sample is presented here. See, last sample is presented infinite, n equal to infinite, and here also last sample is presented n equal to minus infinite, is equal to minus infinite, correct? N is equal to minus infinite. So here you can write minus infinite to 1. Here you can write -2 to infinite, correct? Here you can write minus infinite to 1, guys. Yes or no? Or you can write 1 to minus infinite also. Same thing, guys. You can, if you change the limit of this summation, then there is no change in the x of n. X of n looks like this only, guys. Okay. So here minus infinite to 1. Any doubt in this? Any doubt, guys? Tell me. Okay. You can write minus infinite to 1, or you can write 1 to minus infinite. Both are same. Okay. Very good. Now, suppose I am asking to draw x of n is equal, amplitude is -3, suppose, and del q of -n -2. Tell me, right side, left side, and starting point. Goes right side from the starting point, left side from the starting point. Tell me. So here the left side same sign, left side and same sign. Okay, same sign means start from the n equal to -2 going towards left side. So here it will, but amplitude is what? But sample amplitude is negative this time. Sample amplitude is negative time guys. Here starting from n equal to -2 amplitude is -3. Correct? Left side signal. Right in the this signal x of n impulse train also guys. Impulse train. Amplitude is -3 guys. It start from the -2, -1, -3, -5 and so on guys. In the form of impulse train x of n, tell me summation, tell me guys, here it is same del n minus k, but amplitude is what guys? Amplitude is now this time amplitude is here also guys. Here amplitude is 2 guys. So here you have to write amplitude 2. Here amplitude 3 guys. Here amplitude is 3. And here also you have to write amplitude 2 guys. Don't forget to write amplitude. Correct? Amplitude is 2. So here 2. Here amplitude is 3. That's why 3 guys. And here amplitude is -3. So you can write this is the minus sign. Here 3 guys. Del n minus k. Are you getting? Minus sign guys. So amplitude is negative minus summation 3 del n minus k, and k is from, tell me, k is from minus infinite to -2. Simple. Clear to each and everyone? Okay, very good guys. So minus infinite to -2, minus infinite -2. Now next guys, next suppose I am asking to draw, this is very much important, asking to draw x of n is equal to 2 del 2n minus 3 guys. Tell me where this sample is located, what is the amplitude of that sample. I am expecting answer from each and every single student. This is very much important guys. Okay, so tell me the location of this impulse function guys, where this impulse is located. 0 is not integer, right side signal, amplitude 1, starting point 3. This is impulse only, not u of n, remember, impulse only, not, okay. Location is 3 and amplitude is 2 guys. So let us do it with the standard form. This is not unit step sequence, not the unit step sequence, this is the impulse function. Now see, left hand side, amplitude is 2, left hand side n become 2n minus 3, so right hand side n become 2n minus 3, which is equal to 0. So here this is 2 and n is equal to 3 by 2, n equal to 3 by 2. Now tell me, this 3 by 2 is integer or non-integer? Of course this is non-integer. So non-integer value is not exist, not defined for the discrete time signal guys, discrete time signal. So here as this is what guys? Non-integer value. Non-integer value guys. This is the non-integer value, correct? So that's why this x of n, this impulse function is not defined. You cannot say this is located at 3, or you cannot say this is located at 3 by 2. Okay, this is not defined guys. This signal here non-integer value, hence this x of n is 2 del 2n minus 3 is not defined. Are you getting? Because here non-integer value of n, here non-integer value of n, so that's why here this is not defined, guys. Correct? This is not defined. Not defined. Are you getting? It is not defined, guys. But suppose I am asking to draw or sketch minus 3 del Pn minus 6, guys. Pn minus 6. Then tell me, what is the location of this sample function or impulse function? Tell me, guys. So here amplitude is minus 1, right side starting point is 2, guys. So here amplitude is 3 only, guys. Amplitude is 3 only. See, scaling property says that del, you know that del m into n equal to del n only. Here there is not multiply, we are not multiplying 1 upon mod m, guys. Okay, del mn is equal to del n only, guys. So here you can see x of n is equal to minus 3, and here scaling factor is 3, guys. It will be n minus 2. Compare with this one. Now see, this is the integer value, n minus 2, and 2 is the integer. So this is defined. 2 is integer value, so that's why this impulse function will define at n equal to 2. But here, according to this property, this minus 3 del n minus 2, guys. You getting? N minus 2. Yes or no? So this impulse function present at n equal to 2, having amplitude minus 3, guys. Equal to, getting, n equal to 2. So the amplitude is minus 3, guys. Got it? Is this clear to each and everyone? Yes, amplitude is same. There is no change in amplitude. We are performing the time scaling property, guys. So time scaling operation, the impulse function, discrete impulse function. Any doubt now? Tell me. Any doubt in this? Any doubt in this? Is this clear to each and every student? Is this clear to each and everyone? I hope all the students are getting. Okay. So gradually we will understand all the concept, guys. All the variety I will cover, guys. I will cover all the variety. Okay. One. Okay. So let me finish this lecture here, guys. Okay. Let me finish this lecture here, and I hope all the students are enjoying this type of content on YouTube. No, scaling operation will not not give any effect on the impulse function. Okay, this is the property del mn. I told you guys property already. I told you the different properties. Here you can see del alpha t equal to 1 by mod alpha del t, but this is del mn is equal to del n only. You can see here also, guys. You can see I told you guys already here also, and this is the example. Okay. No, there is no effect in discrete. Okay, so guys, let us finish this lecture here, and please provide your valuable feedback in comment box for each and every class. Okay, your feedback is very much valuable for us. Okay, so please provide your valuable feedback comment box after completion of this session, and next part we will continue into subsequent module. Thank you guys. Thank you so much.